Puma Energy is a large-scale global petroleum corporation that holds themselves to high environmental standards in order to protect the communities and areas they occupy. They abide by all government-regulated permits to safely treat all water that may come in contact with their petroleum products throughout the storage, transfer, and cleaning processes. Puma Energy is also the fuel source of vital industries to Puerto Rico, such as tourism and aviation, providing the means to operate cruise ships and airplanes to and from the island. Puma Energy operates roughly 340 gas stations throughout the island to fuel the abundance of cars. With petroleum accounting for 4/5 of Puerto Rico's energy, Puma Energy supplies major electricity plants, gas stations, and various other energy providers on the island, and thus supports a vast majority of Puerto Rico's power. Without petroleum, the island of Puerto Rico would struggle to function, making Puma Energy's role crucial.
The project that we were tasked with was to research an alternative system for the cost-effective and environmentally responsible treatment of petroleum contact water at Puma Energy's Bayamon terminal. Additionally, Puma Energy asked that we look into the Puerto Rican Aqueduct and Sewer Authority, otherwise known as PRASA, for a permit to discharge the treated water into the sewer system. They sought our help to aid in the process of downsizing their current large, expensive, continuous flow treatment system. Research was pivotal in order to understand and complete the project. We needed to thoroughly investigate the individual contaminants that appeared in the water quality report from Puma Energy in order to find the best treatment strategy and to understand the potential impact on human livelihood. After understanding the water that we were dealing with, we began researching different manufacturing companies. These companies could potentially supply Puma Energy with necessary treatment methods that would maintain the process of the current continuous flow system. By researching manufacturing companies, we were then able to pursue the cost estimates that we needed to provide for Puma Energy.
First, we had to conduct research in order to completely understand the project and what our treatment options were. We investigated petroleum contact water, specific contaminants we were dealing with, and their potential impact on humans. We also had to better understand batch systems and the manufacturers that produce them. We interviewed a WPI professor to improve our understanding of the background research. We remained in constant contact with our sponsor, Puma Energy, in order to completely understand the scope of the project and the details of their current treatment method. We spoke with a representative from PRASA in order to learn more about the permit for sewer discharge. We then had to consult representatives from manufacturing companies in order to explain our needs for a treatment facility. We then had to look at all associated fees for a batch system. There are expenses for the physical system and continued regular maintenance fees after implementation. We also had to consider importation costs, including labor and fuel, and construction fees for installing the system at the terminal. The PRASA permit comes with an annual cost as well. As a result of our findings, we recommend a batch treatment system with manufacturer options and the requirements for the discharge permit.
We recommended that Puma Energy pursue a connection with PRASA by filling out the preliminary questionnaire in order to receive a cost estimate for discharging into the sewer system. In addition, we received multiple price quotes from manufacturers and were able to make educated suggestions to Puma Energy. These suggestions entail a new cost-effective batch system that will continue to properly treat their petroleum contact water for years to come.